So consider this given problem statement. So here let z be the set of integers. So for this z, this is considered as set of integers. If set A contains element x that belongs to z, and the constant is given on this one is that 2 to the power this expression on the exponent, that is x plus 2 times x square minus 5x plus 6 is equal to 1, and the set B is stated as x belonging to set of integers, that is z, and this must follow this particular constraint, that is the expression here 2x minus 1 is strictly greater than -3, and this one is strictly less than 9. So in that case we need to compute the value of number of elements present in A cross B, so that it is not log base 2, it is only number of elements present in A Cartesian product with B. So that is the requirement of the problem statement. Now in this case we can say that the set A which is given here, I'll just jot it down as it is. So from this one we can say that this particular expression, we need to resolve this part. So it's clearly we can observe that this one can be written as 2 to the power 0. This one can be written as 2 to the power 0. And on comparing the exponent, that is x plus 2 times x square minus 5x plus 6 plus 6, this will be equal to 0. And on further factorizing this quadratic factor, that is x square minus 5x plus 6, this can be written as x minus 3 times x minus 2, that is equal to 0. So from this we can say that x belong to this set, that is one will be -2, then we have 2 and other is 3. So the number of, so from this we can say that the number of elements present in set A, that is nothing but 3. Next, now we'll resolve for this particular set, that is for set B. So we need to resolve this particular inequation, right? So what we can do, on all the three sides we can just add 1. So we can just take this particular expression and add 1. So on adding 1, this neutralizes to 0, and this 9 plus 1 becomes 10. So from this we can say that this is -2 less than 2x less than 10. On resolving this further, we can say that this will be -1 dividing 2 all the sides, right? Then we have x and here 5. So from this we can say that x will belong to the set that is containing the integer elements 0, 1, 2, 3 and then 4. So from this we can say that the number of elements present in set B, that will be equal to here 5, total 5 elements are there, right? Yes. Now the demand of the problem statement is that number of elements present in A Cartesian product with B. Now we already know how to find Cartesian product. So we know this fact that the number of elements present in Cartesian product A cross B, that is A Cartesian product B, this will be equal to number of elements in A multiplied by number of elements in B. So the number of elements in set A is 3 because we got 3 solution, and for this one it is 5. So the answer will be 15. So for this given problem statement, the answer will be 15. So I hope it is clear. So the only catch was that we need to resolve this equation, because based on these constraints we can get the value of x, and for this particular inequation, just because I divided all the sides, all three sides by a positive integer, that's why the sign didn't change. Okay. And finally, by using the basic property of Cartesian product, we got the answer is 15. So I hope you enjoyed this problem.